Hi guys, it's Mrs. Smith here. I hope everybody's doing well. So for our notes today, we are going to start looking at classifying angles and different types of angles. I think some of this stuff you guys should be familiar with and have heard before. So we're just going to start by going through some different types of angles here. Okay, so an acute angle is an angle whose measure is between 0 degrees and 90 degrees. Okay, so this is an example. A 35-degree angle would be classified as acute. Okay, an angle whose measure is between 90 degrees and 180 degrees would be an obtuse angle. Okay, so again, this is an example here. If it was 120 degrees, it would be labeled as an obtuse angle. All right. A right angle always has this marking here. So this is how you know it has that right angle marking, and that's a 90-degree angle. Okay, and then we have a straight angle, which is just a straight line, and that would be 180 degrees. Okay, so you've probably heard of those classifications before, but that's just a little review for you. Also, when you hear them talking about the vertex is just the end point where two rays meet to form an angle. Okay, so this right here would be the vertex. Okay, so the end point where the two rays meet to form an angle is called the vertex. Okay, so if we look at this first example, it says name the angle shown in 4 ways, then classify it as acute, right, obtuse, or straight. Okay, so there's one way that we can name an angle. We can look at the vertex and we can simply name it by that angle. Okay, so we could call this angle G, okay, because it has a G by the vertex. It also has a 2 here, so we could also call it angle 2. And if you notice, I'm making these angle notations right before the number or the letter that I'm naming it as. You do need to include that. So a large thing with geometry is notation. Okay, so you do have to have this angle marking. The other way that we could classify this angle is by using 3 letters. Okay, so we could start here and do FGH, so angle FGH. And you always, if you notice, you always want to have the vertex as the middle if you're naming it with 3 letters. So I could also do that in another order. I could also do angle HGF. Okay, so notice my G is the vertex, so that still always has to be in the middle. Okay, so those are 4 different ways that you could name that angle. So angle G, angle 2, angle FGH, or angle HGF. And all of those ways are talking about this angle here. Okay, so now classify it. So if we look at this angle, it says is it acute, right, obtuse, or straight? So we know it's not larger than a 90-degree angle, so it's going to be an acute angle. Okay, so we know it's less than 90 degrees, so that's why it's acute. Okay, so moving on to a couple more examples here. So this next one says name each angle in 4 ways. Again, classify it as acute, right, obtuse, or straight. So same sort of thing here. I can name my angle B. Okay, I can also name it angle 2. And then you could also do it with the 3 letters. So when you're doing it with the 3 letters, again, you just want to make sure that vertex is your middle letter. So I could say angle A, B, C. I could also say angle C, B, A. Okay, and again, just notice that the letter or the vertex is in the middle if you name it with the 3 letters. So for this one, if it has this marking, this is a 90-degree angle because it's showing me that marking there. So this is a right angle. Okay, so that's how I would classify it. All right, so for B, again, I could name this angle angle S. I could also name it by the number angle 3. I could also name it with the 3 letters. So I could do angle RST. I could also do it the opposite way and do angle TSR. Okay, and again, if you're naming it with the 3 letters, you do have to make sure the vertex is that middle letter. For classification here, it's larger than a 90-degree angle, so I know it's going to be obtuse. All right, and then the last one, again, for naming it, we're going to name it angle M, or it could be named angle 4, or it could be named angle LMN, or it could be angled angle NML. Okay, so the 4 ways, and then obviously it's making a straight line, so this would be a straight angle. All right. So those are 4 ways that you can classify an angle, and these are all by the angle measurement. Okay, so there's also some other vocab that we're going to look at. So we're going to look at what it means to be vertical angles. So vertical angles are now comparing 2 angles. So 2 angles are vertical if they're opposite angles formed by the intersection of 2 lines. Okay, vertical angles are congruent. So congruent means that they have the same measurement here. Okay, so they're equal. All right, so congruent basically means they're equal. So you know that if 2 angles are vertical, they also have the same degree. So it gives us some examples here. Angle 1 and angle 3 are vertical. And if you notice some of the notation, you do need to know this for geometry. Okay, so just like we talked about earlier, we have the angle marking here. That means it's an angle. And then this symbol here means congruent. Okay, so you would need to include that notation. Okay, so congruent is basically an equal sign with a little kind of squiggly line on the top. So congruent, equal, is that equal sign with a little squiggly line on the top. Okay, so here they're saying angle 1 is congruent or equal to angle 3. Okay, so angle 1 and angle 3 are congruent. We also know that angle 2 and angle 4 are congruent and vertical because they're opposite of each other. Okay, so we have 2 sets of vertical angles. Okay, we could also say, you know, if we gave these a measurement, so if I said that angle 1 was, I'm just going to make something up here. Let's say angle 1 is 55 degrees. Okay, then we would know that angle 3 would also have to be 55 degrees because they're vertical, which means that they have to have the same measurement, so they're congruent. Okay, so we also have adjacent angles. So adjacent means that they share the same vertex, okay, and they also have a common side, but they don't overlap. Okay, so to be adjacent, they have a common vertex and a common side, but they cannot overlap. So again, if you look at this diagram here, angle 1 and angle 2, they share this common vertex. Okay, they also have this common side here. So angle 1 and angle 2 are adjacent. Okay, same thing with angle 2 and angle 3, right? Angle 2 and angle 3 share a common vertex. They also share a common side. So angle 2 and angle 3, common vertex and common side. Okay, same is true for angle 3 and angle 4. They share that common vertex and they have that common side. And same thing for 4 and 1. Okay, so they're basically next to each other is what they're telling you there. Okay, and it says here you can name an angle by its vertex and by its points. And that's kind of what we talked about earlier. So in example 2, it says identify a pair of vertical angles and adjacent angles in the diagram. Okay, so there's different ones that we could do here. So vertical, well actually vertical, they only give you 3 angles. So it has to be the pair of vertical angles would have to be 3 and 5. So they're opposite of each other. Okay, so I'm going to say angle 3 is congruent vertical to angle 5. Okay, you can also write that angle 3, like you could write angle 3 and angle 5. So these are your vertical angles. I'm just saying they're also congruent, so I know that they're equal. Adjacent angles. So here you have a couple of choices. I could say angle 3 and angle 4, because again, they share that common vertex and the common side. I could also say angle 4 and angle 5. Okay, because again, they also share a common vertex and a common side. Okay, so the last part is using what you know about these angles to find missing measurements. Okay, so in this example, it says, what is the value of x in this figure? So we know that 120 is opposite of 2x, which means that these are vertical angles. We also know that vertical angles are congruent or equal. Okay, so we can kind of set up a little equation here. We know that 120, so this first angle, is going to be equal to its vertical angle of 2x. So if 2x has to be equal to 120, we can say that x is going to be equal to 60 degrees. Okay, so you can either do that by solving the equation, right? So 2 times x, so the inverse operation is division. Or you can just kind of think to yourself, 2 times what gives you the 120, and it would be 60 degrees. Okay, same thing for b here. So if we're trying to figure out what x is, I know that 5x plus 5 is vertical to this right angle. And I know that's a right angle because of the marking. And I know that a right angle is 90 degrees. Okay, so I know that 5x plus 5 is going to be equal to 90 degrees because those two angles are vertical. So now again, I can simply solve the equation. Okay, so I'm going to subtract 5 from both sides. I'm going to get 5x equals 85. And I'm going to divide by 5. Okay, so 5 goes into 8 once with 3 left over. 5 goes into 35 7 times. So x is equal to 17. Okay, so that's how you can use vertical angles to find missing angles. So that's it for the notes. So hopefully you have filled those out. And just take a minute kind of and look back through the notes that you filled out. And for our live meeting, you can kind of determine if you had any questions. So take a minute, look back, make sure you understood anything. And if you didn't, maybe take that to like jot down or star ones that you didn't understand so that when we meet for our live meeting, we can go over those together. All right, I'll see you guys soon.